Hello students, welcome to That's It YouTube channel. In today's class, we are going to learn one of the most important topic of organic chemistry. It is nothing but the pillar to study so many aspects such as the stability of intermediate, reactivity of a particular substrate, acidic or basic nature of the organic compounds. In fact, this also gives us the stability related to the alkenes also. So, it is mandatory for every student or every child to learn the concepts in general organic chemistry through the electronic effects. So, let us start discussing the topic, right. So, electronic effect is a general phenomena, right. This we would come across in our daily life. You see, you just imagine a needy person and he desperately requires your help, right. There are three ways of helping him or her out. Number one, giving them the moral support. That means telling them that you are there for the help. Number two, helping through the money or the support system that you have with you. Suppose I have some money with me and one of my friend is bankrupt, I will give my money to him. This is direct support. Third, suppose I do not have that money, I can borrow it from someone and give it to them. So, there are three ways mainly in which you can help the sufferer. Obviously, one is direct, two are indirect, isn't it? Now, the seeker, you can see here that when you are looking at this perspective or this image, you can make out that this person, you see, this person is taking the help from this guy, indeed who is bonded to the other persons also by some means. This is what you see in inductive effect. So, usually inductive effect is a group effect. What is that? It is a group effect. That means, the whole group, you can see that bunch of three people is helping the needy, right. So, that is what we can see in the compound such as CH3Cl. So, what will happen here is that the greed, we can call that as greed of the chlorine, electronegativity of the chlorine is pacified by the release of sigma electrons of carbon chlorine bond to the chlorine, helping it to garner the partial negative charge. Obviously, the partial positive charge is on the methyl. So, it is a group effect. So, we need to understand here, more the electronegativity, more is the negative charge procured, and this impact is what we call as minus I effect. So, inductive effect, more electronegative element is showing minus I effect. So, the other group that is losing its electrons to the electronegative element, usually it is a group, is said to be showing the plus I effect. That is it. So, sigma electron, you see this bond is actually sigma bond. Sigma bond electron pair loser is said to be showing plus I, which is directly proportional to number of carbon atoms, all right, and also branching. What is the other parameter? Branching. Minus I is directly proportional to electronegativity. That is it. All right. So, inductive effect is the permanent effect caused due to the electronegativity difference. Second one is mesomeric effect. That means, you see, you could see that someone who is in a desperate need of something, maybe hunger, desperate need of food, hungry, is being catered by this generous or courteous lady. So, what I mean to say that such generous group which is said to be having the lone pair of electrons is donating its electrons because its octet is full, so that the octet of the other element or other group can also be catered, so that the hunger is compensated. What I mean to say is that when this donate the lone pair, you could expect what will happen? Resonance will take place, right? OH double bond CH2 plus lone pair. You can see both the atoms, oxygen and carbon, octet is complete, isn't it? So, here the donation of the lone pair of electrons. In the previous case, we have seen the donation of the sigma electrons, alright, due to electronegativity difference. Here, the donation of lone pair or negative charge, so that octet can be completed for the other group, is known as mesomeric effect, or also known as resonance effect, because you can see the resonating structures only. Alright. So, what is the difference between resonance and mesomeric effect? You see, imagine you want to travel on a bike. So, before you start your journey, you have to kick start your bike, isn't it? So, kicking start or kick starting of the bike is mesomeric effect, and the journey is resonance. Suppose you are sitting underneath this ceiling fan. When you switch on the fan will revolve. Switching on the fan is the mesomeric effect. Revolution of the fan is nothing but resonance. So, resonance is two directional, mesomeric effect is unidirectional. I hope you understood. Alright. So, what I mean to say, that here the lone pair donor, inherently the lone pair donor is said to be showing the plus M effect, and seeker is minus M effect. So, this is the summary of the two important aspects known as what you call mesomeric and inductive. Now, let us see minus I and plus I groups depending upon electronegativity, it is how it goes, right? Fluorine, chlorine, all that. You can see all these groups are the minus negative induct effect showing groups, whereas the other side you can see that positive inductive effect showing group. I hope you understood. All right, clear? So, just take the screenshot if possible. Now, mesomeric effect, that is what we found, that the species, any species with the lone pair of electrons, it could be NH2, it could be OH, O minus, or a species which is having indeed the double bond, because even pi electrons can be donated. It is all acid based concept only. So, lone pairs are donated to this, so that this positive charge can be nullified, isn't it? So, what is going to happen here? So, everybody is happy after this donation, because octet of every atom is complete. That is what we call as mesomeric effect. All right. So, let us see the plus M showing group. More the electron density on the central atom, more is the plus M. O minus, NH2, NHR, OR, NHCOR, OCOR, pH. This is the order generally. All right. So, you may be wondering, sir, here you see oxygen has more electronegativity, how can it be a good donor? You need to understand that the size of oxygen is too small, that it has a negative charge which it can't afford, want to donate quickly. So, O with negative charge. All right. So, this is the order minus M, that means electron seeker is NO2 champion, and likewise I gave the order. I want you to take this screenshot of this order. Memorization is very important. All right. Next, I told you that you doesn't have the money to donate, but you can borrow it from one of your friend and give it to the needy. That we can do, isn't it? I don't have that direct support system. For example, see, there is a seeker of electron, there is some guy who is suffering from electron deficiency, and he is attached to, say, the carbon atom. You know that carbon does not carry any lone pair, but you see it is binded to the hydrogen. So, what this can do is it can donate the bond pair of electrons to it. Bond pair of electrons are donated. This is also indirect help, right? So, this bond is broken, so that this minus can be pacifying the plus. And you say actually help is rendered by the hydrogen atom or through the sigma bond of the carbon hydrogen, isn't it? So, we can give the credit or this whole phenomena called as hyperconjugation, which is otherwise called as Baker-Nathan effect or sigma pi resonance. The credit is given to the alpha hydrogens, right? These are called alpha. So, hyperconjugation, if you want to measure, it is the number of alpha hydrogen atom. That is what is happening, you can see. So, this guy is seeker, empty orbital, and this bond pair of electrons, this CH bond pair of electrons, that means highly occupied molecular orbital, is going to donate its electrons partially, so that this can form a new bond between these two. That means, here you see what will happen, the double bond will be formed here, hydrogen will be relentlessly waiting for its own electrons. That is why it is called no bond resonance or sigma pi resonance also. Hope you understood, isn't it? So, more the alpha hydrogen atom, more is the what you call the phenomena called as hyperconjugation, right. So, any group which has alpha hydrogen, for example, you have methyl and ethyl. If you are comparing which group relatively show more hyperconjugation, you must say methyl, because it has got 3 alpha hydrogen atom. Ethyl has only 2 alpha. You should not count beta. If there is a needy here, this is alpha. You should count total alpha hydrogen atom. More the alpha hydrogen atom, more is considered to be the hyperconjugation. So, that is what this is the summary of the electronic effects. We are going to see the application, right. Once you study the theoretical part, then you will see how do I apply this particular important topic on to the stability, acidic or basic properties, right. So, that we are going to see in the coming classes. That is all for today. If you have liked the classes, please like, share and subscribe to the That's It YouTube channel, because I am going to provide you such a content every week at free of cost. So, this will benefit the students who did not understand the topic by chance, alright, but your single like button press or subscription would help me a lot, encourage the teacher, build the society. That is it.